Welcome back to For the Mariners by the Mariners channel. In the high-stakes environment of a ship engine room, achieving perfect combustion is the ultimate goal for every marine engineer, and monitoring the exhaust gas oxygen content is the most reliable way to measure this efficiency. When fuel is burned in the massive cylinders of a marine engine, it requires a specific amount of air to react completely, and the level of oxygen remaining in the exhaust gas tells us exactly how well that balance has been struck. If there is too little oxygen remaining in the exhaust, it indicates a rich mixture where fuel is being wasted and incomplete combustion is occurring, leading to heavy soot deposits, carbon buildup, and high carbon monoxide emissions. Conversely, too much oxygen suggests an overly lean mixture which can lead to high nitrogen oxide formation and reduced thermal efficiency as energy is wasted, heating up excess air that does not contribute to the power stroke. This is why the oxygen analyzer is a critical diagnostic tool for real-time combustion optimization. Most modern marine vessels utilize zirconium dioxide sensors or paramagnetic sensors to provide a continuous reading of the oxygen percentage in the flue gas. The zirconium sensor operates on the principle of oxygen ion conductivity at high temperatures, creating a small voltage that is proportional to the difference in oxygen concentration between the exhaust gas and a reference air sample. This data allows the engine control system or the duty engineer to adjust the air-fuel ratio precisely, ensuring that the engine operates as close to the stoichiometric point as possible while maintaining a safe margin of excess air. By keeping the oxygen levels within the manufacturer recommended range, typically between 5 and 10% for most large diesel engines, you ensure that fuel consumption is minimized and the internal components of the engine stay cleaner for longer periods. Accurate oxygen analysis also plays a vital role in environmental compliance, as it is used to calculate the specific emission levels required by international maritime regulations. During your maintenance routine, it is essential to calibrate the oxygen sensors regularly using span and zero gases to prevent drift in the readings. You must also ensure that the sampling probes are free from soot and that the cooling and filtration system for the exhaust gas sample is functioning correctly to protect the sensitive sensor elements. A drop in oxygen readings could be a sign of a restricted air intake or a failing turbocharger, while a sudden spike might indicate a leaking exhaust valve or a malfunctioning fuel injector. By integrating oxygen analysis into your daily engine monitoring routine, you can detect these issues before they lead to increased operating costs or mechanical failure. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share, and subscribe for more insights. Thank you.